My name is Raheb HAFEZZADEH. I'm a PhD student from the University of Parma. Today I'm here to talk about repairing road pavement potholes with cold mix patching materials. Potholes are road pavement localized distress that form due to loss of materials. They threat the pavement durability, and also they are a threat to traffic safety. For example, 1% of the accidents and deaths in 2018 and 2019 in India was happened due to potholes. Therefore, they should be repaired as soon as possible. However, it costs millions of dollars. In 1978, the United States spent almost $1 billion to repair 160 million potholes. In 2012 to 2014, England spent more than 200 million pounds to repair potholes. Usually, bituminous materials like hot mixed asphalt and cold mixed asphalt are used to repair potholes. However, we should consider that potholes usually grow and extend during winter time when we don't have accessibilities to hot mix asphalt plants. Also, the weather temperature is low to apply and compact hot mix asphalt. Therefore, for repairing potholes, cold mix asphalt or cold mix patching materials are considered, as they are compatible with adverse weather. They can be packed in small quantities. Also, they can be stockpiled near the job site. Their application is easy. They are environmentally friendly, and they need few crew and equipment to do their job. Pothole repair operations include temporary, semi-permanent, and permanent methods. However, it is recommended to road maintenance agencies to consider a permanent method as their first choice and use temporary methods just for providing the traffic and safety. Therefore, cold mix patching materials are used as a temporary method to solve the problem temporarily until a durable and permanent method and solution is applied. There are three methods to apply cold mix patching materials. However, the through and roll method is the most common method to use this material. In this case, the material is placed into the pothole, and then the material is compacted with food, with hand tamper, and truck tire. Although cold mix patching materials have a short application time to patch the pothole quickly, they are the lowest quality of all patching materials. As they have low initial stability, they have poor workability, especially in cold weather. They are high porous materials and have weak early strength, and they have poor bonding, and also they have raveling problems. However, if the cold mix patching material used to repair potholes is a high quality material, it can last longer. The annualized expenditure per repair for various materials costing from $30 to $120 per ton was considered in a study by Anderson et al. The result of his research showed that if the most expensive material is considered to repair the pothole, and if this material lasts until the second year, the cost that is required to repair the damages will be less than the cost that is required to repair the damages with a cheap material after just 1 year. So it is recommended to repair potholes with a high quality material if it is also expensive, because in the long run it will be cost effective. There are many factors that affect the performance of these materials, like compaction pressure, material workability. The materials, operation condition, temperature, curing rate, quality of the materials that we already talked about it. Performance investigation of these materials in the field is performed by pavement engineers visually or in the laboratory by conducting some tests. There are many test methods that have been considered by researchers to analyze and evaluate the performance of these materials. For example, for workability, they consider the penetrometer or spatula or cold or some test to analyze the workability, or for stability, ITS or Marshall stability wheel track test have been considered by researchers. However, and also for the other tests. However, the question is this: that are these test methods suitable to analyze the performance of these materials or not? The results of the research and the literature shows that there are no reasonable correlations between the field and lab results. Also, researchers have used some specific expensive devices that are not available in most of the laboratories. In some cases, also, the test methods are not compatible with all types of the cold mixed matching materials. For example, there are some types of cold mixed matching materials in the market that work well in the field. However, it's not possible to make specimens with them and testing them, because after demolding, the specimen is collapsed. For solving this problem, researchers have aged and cured the material before making the specimens to give the specimens enough stability. However, this aging process doesn't show the behavior of the materials immediately after patching. In conclusion, cold mix patching materials are quickly developing for patching potholes as suitable alternatives to hot mix asphalt. There are still limitations and issues with their mix design and performance evaluation. The performance evaluation approaches do not always meet the requirements of cold mix patching materials, as the test methods for evaluating the performance of these materials usually have been borrowed from the concept of hot mix asphalt and have not been specifically designed for evaluating these materials. So there is a conflict between the field and lab results. New procedures, methods, standards are required to evaluate the performance of these materials that this subject has been considered in my PhD thesis and my PhD study in the University of Parma. Thank you for your attention.